very delighted and humbled to have you tonight. It is teacher Sulait who has come to talk about the physics of junior level, and that is a topic of force. So tonight we want to pragmatically see what force is all about. What do we expect at the end of this topic? So that is the concept of force for today. So dear viewers, when you hear the word force, what goes into your mind? We have had different organizations. You hear people calling themselves a group of force, an organization of force. You hear Uganda, police force, a lot, So what is force? What goes into your mind when you talk about force? People are talking about change in position. Exactly. That is part of motion. But again, we are going to see that force is the basis of motion. If force is not with us, then most of the exercises, the activities which are taking place in this world may not be in a position to take place. So we need to talk about force from a more informed position. So today we are going to discover, by definition, that force is anything. Force is anything that changes. My marker is so faint. Anything that changes the body's state of rest. The body's state of rest. Or uniform motion. Or uniform motion in a straight line. In a straight line. So that is force. If something has been resting and its state of rest is tampered with, and then it starts moving, if it can stop moving, for example, if a car has been moving and its state of motion is tampered with, then there is a force, and that can be a braking force. If something has been resting somewhere, you pick it, it has gone into motion because of a force. So how did this happen? Who developed this concept of force? We are going to realize today that the concept of force was developed by an English scientist by names of Sir Isaac Newton. He's the one who developed the concept of force. During some pandemic in England, this gentleman went back to his village, that is the village of Woolsworth. So when he was sitting under an apple tree, then an apple came and hit him. That's what we hear. It hit him from the tree. Then the gentleman was so inquisitive. Why didn't the apple move upwards? Why did it come downwards? So that's when he discovered a force of gravity, that all free-falling bodies, if I happen to throw my marker upwards, the marker is attracted down the earth. We are going to talk about all that. Take a look at a parachutist who jumps off from a fast-moving plane, and his forces are balanced. He will land onto the ground. People, after discovering the concept of force, they were in position to think about transport means. For example, the aeroplanes, flying in air, the divers, air divers. Can you imagine? Because they know how to counterbalance this force such that it is safe to move into any particular medium. So that is about force. We have a lot about the concept of force. However, the concept of force goes concurrently with the concept of motion. Because once a force acts, you expect two things: motion, removing, or motion, bringing or coming to rest. A body is brought to rest, or a body is set into motion. That's when a force acts. That's why we are saying that force is anything that changes the body's state of rest. When we talk of a body in physics is a general term to mean anything. It can be a human being, it can be anything that is a body in physics. So force being anything that changes the body's state of rest, something which is resting here, can be pulled or can be pushed away to cause or to bring about motion. So some people can define force as a pull or push of anything. Oh, very interesting. A pull or push of anything or of something. So we can also put that one down, that all force is a pull. Force is a pull or push of something. So what do we see from this? We are seeing that a pull can cause motion, okay, or can stop motion. If something has been moving and you happen to pull it, its motion can stop. And if something has been at rest and then you try to push it, still its motion can start or can stop. So we are saying that force is a pull or push of something. Is a pull or push of something. Now, we need to know what are we supposed to cover under this topic of force. Immediately after a break, we are going to outline for you at the end of this topic what are you supposed to be in position to know and then to be well versed with. Immediately after a break, Teacher Sulait is coming back with the site. Stay tuned. Yes, dear viewers, we'll be back from the break. So, at the end of the topic, each of you should be in position to define force. We have already defined the force, so that is a goal achieved. So we should be in position to recognize that force may produce a change in size and shape of a body. We are going to see that the change in size and shape of different bodies is as a result of force. Then we should also recall and use the relationship F is equal to ma, that force is the same as the product of mass times acceleration. And we are going to see that this is from the definition of force, that anything that can change a body's state of rest. However, a body has some quantity of matter, which is mass. And the body's state of rest being changed, that is acceleration. If you are bringing a body to rest, still that is an acceleration, which is negative, a deceleration. Change in speed in a given direction over change in time. So which is acceleration. So people should be knowing this. Okay? Then people should state the different types of force. We are going to see these different types of force. Then you should also be in position to describe motion in a circular path as a result of a perpendicular force, which is towards the center of that circular path. We are going to see that. Then also you should be in position to describe the ways in which force may change motion of a body. Then you should also describe quantitatively and use the concept of weight as the effect of gravitational field on a mass. Weight as a force is the effect of gravitation. When we throw something upwards, its weight brings about attraction towards the Earth's surface, because weight acts vertically downwards, and we are going to recognize it as one of the types of forces. Also, we should be in position to find the resultant of two or more forces acting along the same line. Okay? Two or more forces. If at all I come and pull a body, another person also comes and is fighting for the same body, another one pulls it sideways, another one also pulls it to the left, then where is the resultant? Where will the body move? And from here we are going to see that the direction of the resultant force is the direction of the acceleration. So acceleration always takes place in the direction of the resultant force. In other words, motion is towards the direction of the resultant force. That if you go and push a car, the force you are put on is just an applied force. But a force which brings about motion is totally different from the applied force. So you need to get the whole applied force, then subtract off only that accelerating force, which we are going to use in this equation. F is equal to ma. So people should be in position, I would have put it here, to distinguish between an applied force and an accelerating force. Applied force and force which causes motion. They are two different aspects. If I apply a force of 80, okay, on a body, and a body is moving at a force, or a force which causes motion is only 60, then it means there is a difference, okay? A difference. Some force which was wasted, maybe to overcome a lot of resistances, to overcome the weight of the body. So there is that force. So the applied force is always different from the accelerating force. So you should also be in position to recognize that there is no resultant force. If a body, there is no resultant force on a body, if it remains at rest. At rest position, resultant force on the body is 0. Then also if a body is moving at a constant speed means speed is not changing. The speed which was at a time t1 is the same speed at a time t2. Yet acceleration is change in speed over change in time or over time taken. So if the speed is not changing, if it is 10 at time t and 10 at a time t2, then 10 minus 10, that is 0. And then our quotient or the division of speed in a given direction with time is going to give us a 0. And once the acceleration becomes 0, automatically force also becomes 0. So one of the factors which affect force is going to be acceleration of the body. But what brings about acceleration is the speed, or what we call velocity. So if a body remains at rest, there is no acceleration. The force is 0, resultant force. We are talking about resultant force. When a body continues to move at a constant speed, a speed which is not changing, we are also going to see that the force is 0. Then you should also be in position to recognize air resistance as a form of friction. Then for the international students, under the concept of force, you should also add there what we call elasticity. You should add there what we call Hooke's law. Yes, we are going to talk about Hooke's law under this concept. But now for the local students, this is what we are going to talk about. So immediately after a break, we are coming with the real beginning of this force. From the definition of force, can we get to know the SI unit of force? Since a physical quantity in physics should have a unit, since force is given by mass and acceleration, then what is its unit? Oh, we are coming. And we are also going to talk about facts about force. How force can change direction of the body, how back from the break. I'm very delighted to have you tonight. So we want to see mathematically how is this force expressed, and that is the relationship between force, mass and acceleration. So we are going to see that mathematically, okay, force F is equal to mass M times acceleration of a body, acceleration A. So we are going to introduce this formula. F is equal to ma. Oh, a very, very wonderful formula. So you need to memorize this. This is the father of physics and even mathematics, applied math. If you don't know that F is equal to ma, and F does not stand for applied force but resultant force, then the physics is not going to be up to a level we need. So the SI unit of force, we need to talk about it. And how do we define it? From this formula. So we are going to say that SI unit, those who are making notes, we try to be organized. SI unit of force is a Newton. So underline this. So SI unit of force is a Newton. From the gentleman who developed it, then he gave us his name as the SI unit. We have two theories. Other people say that a Newton was developed by scientists in commemoration of this gentleman who lived in the 16th century. A gentleman who died on 25th of December 1642. That is Sir Isaac Newton. Then others have it that to give force an SI unit of a Newton, it was from Newton's outlook. That Newton saw it very wise. That the scholars of physics are going to find it difficult to say that the SI unit of force is a kilogram meter per square seconds. Remember, mass is measured in kilograms, whereas acceleration is measured in meters per square seconds. So Sir Isaac Newton saw this as a so big unit for the young physics scholars. So he called this his name. That is the second theory which we have. And then the theory asserts that he went ahead to define a Newton basing on this. What is he basing on? He's basing on F is equal to ma, which F is saying is measured in his name. Then mass is measured in kilogram and acceleration in meters per square second. So we have seen that force is equal to mass times acceleration. F is equal to ma. But now we are getting to know where does the unit of force, a Newton, comes from. It is asserted that Sir Isaac Newton, after seeing that a kilogram meter per square second being so big for physics scholars, then he called it his name. We are now seeing that force being measured in newtons, and then mass measured in kilograms, acceleration in meters per square seconds. We can now define what we call a Newton. He went ahead to define a Newton. So dear members, what is a Newton? According to the clue I've given you so far, what is a Newton? Oh, so we are going to realize that a Newton is just a force that gives a mass of 1 kilogram and an acceleration of 1 meter per square second. You see, physics is totally a unique subject. When we tell you to define an SI unit of a physical quantity, then we want you to define it using a mathematical relation. Most of the physical quantities are mathematically related. Look at density, mass over volume. Look at pressure, force over area. Look at velocity, displacement over time. Look at speed, distance over time. Look at acceleration, velocity over time. That is a mathematical formula. So when we are defining SI units of different physical quantities, we don't just state it as a unit of a physical quantity. No, we define it in terms of other physical quantities and their SI units. I repeat, we define an SI unit of a physical quantity in terms of other physical quantities and their SI units. Take a look at a Newton. We are saying a Newton is a force that gives a mass of 1 kilogram and an acceleration of 1 meter per square seconds. So of the two theories, I normally want to go with this theory, the second theory, which asserts that Newton is the one which called the SI unit of force his name, other than those who say that the SI unit Newton was developed in commemoration of Sir Isaac Newton, a great English scientist. So those are the two theories, but we shall go with this. So Newton, after seeing that this is so big, then we saw some other scholars coming in also defining SI units of their discoveries by their names. For example, a gentleman, Prescott Joule, Prescott Joule defined work done. We know very well that work done, SI unit of work as a joule. And in this he was using Newton's name, which is a Newton, and then a distance, which is a meter. And he's saying that, or he said that a joule is the work done when a force of 1 Newton moves a body through a distance of 1 meter. Are you seeing how we are defining SI units of different physical quantities? Not just a mere saying that a joule is the SI unit of work done. No. But we are defining in terms of these other quantities and their SI units. In terms of 1 1. You are seeing a kilogram, 1 meter per second. That is an acceleration. Because we are dealing with a Newton, just 1. Then there came watt. From power is equal to work done over time taken. So a watt is the unit of power, and it is measured in work done, which work done is in joules, and then the time is in seconds. So a watt is going to be the power developed when work of 1 joule is done in 1 second. The reason why I've brought these other physical quantities is to give you a baseline for how we define physical units of different physical quantities in physics. So a Newton is the force that gives a mass of 1 kilogram and acceleration of 1 meter per square second. If this is a mass and it is of 1 kilogram, a force which will give it an acceleration of 1 meter per square second is what we are calling a Newton. Since when a force is applied on a body, makes it move, makes it accelerate, makes it to be in motion, brings about movement. So we can go and define a Newton. A Newton is a force that gives a mass of 1 kilogram and an acceleration of 1 meter per square seconds. So that is what we call a Newton. This is an examinable definition. People will ask you to define a Newton.